augmented reality tracking system and computer vision. This is Dr. M. Prakash, professor from the Department of Mechanical Engineering, SRM Institute of Science and Technology. The content of this course is the characteristics of tracking technology, stationary tracking system, and computer vision for AR, in which the characteristics of tracking technology, the in-depth of studies related to the physical phenomena, measurement principles, measurement geometric property, sensor arrangement, signal sources, degrees of freedom, measurement coordinates, spatial sensor arrangements, and workspace coverages, and measurement error and temporal characteristics are going to be studied. In a stationary tracking system, it related to the mechanical, electromechanical, and ultrasonic tracking systems are in detail is going to be discussed. And computer vision for AR and marker tracking, multiple camera infrared tracking, natural feature tracking by detection and incremental tracking, and simultaneous localization and mapping SLAM and outdoor tracking. So in the part 1, the characteristics of tracking technology. The tracking technology is one of the most critical component of an augmented reality system because it determines the position, orientation, and movement of the users, devices, and objects in the real time, ensuring that the virtual content remains accurately aligned with the physical world. The performance of AR system largely depends on the characteristics of a tracking technology. And the characteristics of tracking technology, we can able to combine with the real world environment of the human brain. An AR tracking framework is have a real environment, and we have a sensor to capture the images, and then tracking system and position and orientation of the estimation the virtual object and rendering the object. Then we are creating the augmented reality. It may be classified in 3 types. One is vision-based or sensor-based tracking and hybrid tracking. So these are the 3 different tracking methods used in augmented reality. The 20 key characteristics of tracking technology is going to be discussed in the furthermost slide in detail. These are all accuracy, precision, robustness, stability, low latency, and real-time performance, degrees of freedom, scalability, adaptability, range, reliability, occlusion tolerance, and environmental awareness, sensor fusion capability, and computational efficiency, drift resistance, calibration simplicity, and user mobility support, and multi-object tracking, and the last one is the cost effectiveness. So each one has some advantages as well as disadvantages also, and description is in detail we are going to be studying in the furthermost slides. And it also has some challenges related to the AR technology implementations. So the 20 key characteristics of the tracking technology in ARs are discussed in detail. And accuracy, its closeness to the tracked position to the actual real world position, ensure the correct virtual object placements. In a precision, consistency of the repeated tracking measurements produces a stable and consistent results. In a robustness, the ability to work reliability under varying conditions like lighting, occlusion, and fast movement, and it maintains the tracking in challenging environment. Stability, the virtual object remains fixed and steady in the environment, prevents the trips and jitter. In low latency, minimal the delay between the user movement and the system responses. The ideal latency is less than 20 milliseconds for the smooth AR experience. And real-time performance, the continuous updates, position, and direction of the instantly, enables the live interaction and immediate feedback. Degrees of freedom tracks the full motion in 3-dimensional spaces along X, Y, and Z axis in translation, rotation, pitch, row, and yaw. And scalability is the work is different environment sizes, the small rooms to the larger outdoor area, suitable for diverse applications. Adaptability adjusts to environmental changes and automatically like lighting, weather, and surfaces. The range, effectiveness of the distance for which tracking works. It may be the short, medium, and long ranges. Reliability, maintain the accurate tracking over a long period without failure. And occlusion and tolerances, it's making the continuous tracking even when the objects are partially hidden. Prevents the tracking loss during the occlusion. And environmental awareness, in which understand the maps, surrounding surfaces, and objects' depth of perception. So the things being involved in environmental awareness. It supports the scene, understanding, and interacting with the real world. Sensor fusion capability. It integrated with camera and IMU and then GPS and LiDAR system combines the data from multiple sensors to better accuracy and robustness. And computational efficiency, use the minimal processing resources, ensure the largest battery life and the faster performance. Drift assessment is a position error with respect to the time. Without drift, it can be concluded. And calibration simplicity, easy to set up and calibrate, faster development and lower maintenance cost. User mobility support, support the free movement of users in the environment. Importance for the navigation is going to be takes place here. And multi-objective tracking, like in real world as well as the dynamic static objects are going to be tracked in natural manner. And cost effectiveness, high performance with reasonable hardware and maintenance cost ensure the economic feasibility for the large scale users. So these are the 20 key characteristics from the tracking technology that determines all the position, orientation, and movement of the user, devices, and object, as well as the interaction effectively to the real life to the virtual world. And the performance metrics for the tracking system is only considering the limited aspects, and accuracy indicating the correct position estimation, precision the consistent measurement, and stability reduce the object drift, and latency the response delay, and reliability continuous operations, and robustness performance under varying conditions, and scalability support for different environments, and adaptability handle the overall environmental changes. So the characteristics of different tracking technology like marker-based, markerless-based, CPS tracking, LiDAR tracking, and hybrid tracking, accuracy, range, cost, and robustness is compared in detail about this. In which the accuracy high in the case of a marker-based and hybrid tracking also having a very high accuracy. And robustness is also going to be high in the case of hybrid tracking, but the cost effectiveness is very high in nature of hybrid tracking. And next one is the physical phenomena in tracking technology for augmented reality. Tracking technology in augmented reality relies on several physical phenomena which will determine the position, orientation, movement, and interaction of the users and the objects in the real environment. These phenomena are based on the principles of optics, electromagnetism, mechanism, and then acoustic and radio propagation. Based on that, the sensor signal is going to be taken for and analyzing that virtual to the real world. Understanding these physical phenomena is essential for designing accurate, robust, and reliable AR tracking system. And these are the 4 different types of physical phenomena in AR tracking system: optical, electromagnetic, mechanical, and acoustic tracking. In optical tracking, most probably the RGB, red, green, blue nature of the optical image is going to be taken, and camera is in the simple objects going to be captured the images in the real world. And LiDAR, light detection, ranging, and then for infrared tracking and the depth sensor, the structured light of light is going to be taken here. This is the physical principle behind that. One is the reflection of light and refraction of light and the image formation and pattern recognition. And for electromagnetic tracking, relies on electromagnetic fields and radio waves for the position and orientation estimation. It may be in GPS, that is called Global Positioning System, user radio signals from the satellite, provide the global position like latitude, longitude, and altitude. And RFID, radio frequency identification, uses radio waves to identify the tags used for objects and assets tracking in indoor environment. And for magnetic tracking, measures the Earth magnetic field used for the orientation and getting estimation. So this is the physical principle behind that: electromagnetic induction, radio perception, magnetic field measurement. The third one is the mechanical tracking. The principle behind is very simple, linear, and accelerations with respect to the Newton's law of motions. Based on the motion of mechanical movement like accelerometer, gyroscope, and then form, both of them integrated with them, that is called inertial measurement unit, IMU. It will indicating the accelerometer and gyroscope along with the magnetic meter. And acoustic tracking uses sound waves and the propagation characteristics for tracking. It's indicating the ultrasonic sensor emit the high frequency sound waves, measure the echo to calculate the distance, useful for the indoor. Another one is a sonar, sound navigation and ranging, uses sound waves in air and water. The measures of distance based on the echo delay. So it will using the principle behind the sound wave propagation. Another one is a time called as a time of flight. So making the comparison in the physical phenomena, the phenomena like optical, magnetic, mechanical, acoustic, infrared, laser, each one have some technological aspects and accuracy and ranges are. Very high accuracy is given by the laser, but the medium range is given. Long range is given by the electromagnetic radiations. And for the mechanical and other aspects, you only find the short range. This slide indicating that measurement principle in tracking technology for augmented reality. Whatever we discussed in the earlier slides, the combination of all the things going to be discussed in detail about this. And for the position measurement principles and orientation measurement principle, distance measurement principles, angle measurement principle, accelerometer measurement principle, and velocity measurement principles. The measurement principles in tracking technology for augmented reality is going to be know about that position, orientation, distance, angle, acceleration, and motions. So the position measurement or its orientation measurement determines the locations of an object within the coordinate system. It may be useful for the Cartesian coordinate system in which global, world, and camera coordination system is to be used. Sometimes it may be called as a user coordinate system. For an optical tracking, we are using the image coordination, GPS tracking using a satellite integration, triangulations, and for LiDAR tracking using the laser ranging, and IMU tracking using motion integrations. For in a case of an orientation with respect to X, Y, Z, we are going to be use a gyroscope, magnetometer, and camera by measuring X, Y, Z axis along with the roll pitch here. And for the distance measurement, they're measured by with the help of the distance to determine the separation between the two points or paths. The method one is actually called as a time of flight, in which we are using the LiDAR, infrared sensor, ultrasonic sensor. The principle behind is a signal is transmitted and reflected back. Distance is calculated from the travel time. So T equal to Vt by 2, where the T is a distance and V is a signal velocity and the T is a round trip, indicating the depth sensing, spatial mapping, and object localization. In the case of an angle measurement, the principle behind that is omega equal to d theta by t with the help of gyroscope and magnetometer is measured. And acceleration measured with the help of an accelerometer, in which the rate of change of velocity is identified, and the basic principle is Newton's second law of motion. The sensor used here is actually accelerometer. It measures the linear acceleration and device movement. Application is mainly in jet tracking and motion tracking. In the case of an velocity tracking, velocity determines how faster the objects move and in which direction. Using a GPS, optical tracking, and IMU, V equal to Ts by Tt is a principle behind that. In a case of an optical measurement principle, use light reflection and image formation. We are using the sensor related to RGB, infrared, and depth camera, LiDAR. And then for the processor, light, object, reflection, camera, and image processing, it will identify the position, orientation, shape, and medium. In triangulation method, the camera A and B, like in binocular observations, we will made the orientation of the object is identified in triangulation measurement principle. And stereo vision measurement principles uses two images captured from the different viewpoints, and the human binocular vision is going to be taken. The depth and orientation can be measured easily. GPS measurement uses the satellite signals to determine the geographical position and radio signal propagation. And magnetic measurement uses the Earth magnetic field. And inertial measurement principle using accelerometer, gyroscope, and magnetometer combined together. Acoustic measurement and depth measurements are studied in detail in the earlier slide. So the sensor fusion is one among the technology here. And fundamental qualities of measured in AR tracking is quantity is position, orientation, velocity, acceleration, distance, depth, time, and angle. The object location in space is measured by position, direction or rotation is measured by orientation, speed and direction is measured by velocity, rate of velocity change is measured by accelerometer, separation between the object is measured by the distance, and relative distance from the camera is measured by the temp. And similarly, the angle and time can be measured from the individual signal durations. What are the things you are measured? The measured geometric properties are tracking in augmented reality requires a continuous measurement of geometric properties of users, devices, and real-world objects. Why geometric properties is a matter? Because it will identify the location, orientation, distance, shape, size, motion, depth relationship. So geometric properties are necessary to measure. And measured geometric properties are this one: position measurement, distance, depth measurement, and scale measurement. And other things, whatever we discussed in the earlier slides, is also going to be used here. But the thing is, what type of geometric properties we are going to be used is it's a matter of measurements actually. So the position, what it's measured, the location of the object, key technology is it is comparison of measured geometric properties are given here. And finally, the key role for AR tracking is going to be identify the all 5 parameters like position, orientation, distance, depth, and scale. And the challenges in which the geometric properties to measure is sensor noise, lighting differences, and then for variations, and for occlusion and the movement of the objects, which will creating the blurry nature and calibration error. And benefits of accurate geometric measurement is it will increase in accurate reconnaissance or registration and improved realism and better spatial understanding and enhance the user interaction and reliability in nature. And measure the geometric properties in taking other than that is shape measurement, surface geometrical measurement, velocity measurement, acceleration measurement, angular measurement, future point measurement, relative position measurement, and facial relationship measurement. The last one is a force measurement. So in a shape measurement, the shape measurement identifies the object geometry by means of edges, corners, curves, and surface boundaries. Edge detection identifies the object boundaries. Contour analysis extracting the object shape, and feature detection finds the key geometrical features. In the case of surface geometry measurements, definitions, the surface geometry describes the structure of an object surfaces. It will be created by the flat surface, curved surface, and complex surfaces. Using the LiDAR, structured lights, or a depth camera, we can able to get back about the surface inspection, reverse engineering, and digital twins. In velocity measurement, the velocity describes how quickly an object moves from in which direction. And using these technological measurements, we can know about the movement of the object. Acceleration measurement. Acceleration is the rate of change of velocity. Accelerometer is going to be used. The motion tracking and gesture recognition is one among the principal or applications related with that. And angular measurement indicates an angular position, angular velocity, angular acceleration. We are using gyroscope and magnetometer, the application head tracking and robust application. Future point measurement, computer vision tracks, it's creating the distinct images, which will call as in the future. So many of the algorithms are going to be used here to identify the features here, and these algorithms are listed here. And relative position measurement, measure the position of object relative to the another one. When there is not to be avoid the collision between the various objects in the realistical aspects. Spatial relationship measurement determines how objects are arranged in a space. It will indicate in the distance relationship, orientation relationship, adjacency, and connectivity. The pose measurement is pose combine the position and orientation. So x, y, z, and rotation like pitch, roll, yaw is going to be combined together to identify the pose. Okay. So geometric properties as measurement technologies are position, orientation, distance, depth, shape, scale, velocity, and pose. These are the things are discussed in the earlier slide. So each one having the different technological aspects. GPS camera and LiDAR is going to be given for position. Orientation is measured by gyroscope and magnetometer, and distance is LiDAR and ultrasonic. Depth is measured by stereo vision and time of flight camera. And computer vision is using for identifying the shape. Scale vision system is used to measure the scale, and velocity is by GPS and IMU. Force measurement is SLAM sensor fusions. And how these sensors are arranged to get to know about all the details in elaborate manner. So for FR application to correctly position and render the virtual objects, they need to constant the stream of information about the user device, its surrounding and the user's movement. This data is collected by an array of sensors and input methods in AI. So we have the camera. The camera is arguably most critical sensor in sensory device. So it will use to track the future points, recognize the object surfaces, estimate the lighting, and provide the visual information and accuracy. And inertial measurement unit, it will combine the accelerometer and gyroscope, so that x, y, z, and then for pitch, roll, yaw, orientation going to be taken from here. And global positioning system GPS, location-based AR or large-scale AR experiences, in which the tracking AR experience when the user enters the specific geographical area. The large-scale AR experience providing the broad initial position for experience span large outdoor area. In magnetometer, the earth magnetic field acting as a digital canvas, it helps determine the device orientation relative to the magnetic north, which is useful to direction of an AR experiences. In a depth sensor is LiDAR and time of flight. It measures the distance, enhance the scene understanding, improve the tracking robustness. Provide the high accurate information in that about the geometry of the surrounding, enabling the more precise placement of virtual objects, realistic occlusion, and better understanding and surface plans. And This slide indicating about the sensors and input methods. The eyes and ears of an augmented reality are sensor. For AR application to correctly position and render the visual object, they need a constant stream of information about the user device, its surroundings and the user movements. The camera is called as an eyes of ear. IMU is taken an accelerometer and gyroscope. Global positioning system is localization of large-scale air experiences. It will estimate the lighting and provide the visual information for occultism. And magnetometer detects and determine the device orientation, and depth sensor measure the distance, enhance the scene understanding and improve that. So whatever we discussed in the earlier slides, it's combined effect is given in this particular portions. So the viewers can able to get in detail information from the earlier slides. And how we are communicating with the augmented web. So we must be know about the input methods. Beyond simply sensing the environment, sensor and input methods in AR also refers to how users interact with the digital content. So the first more important thing is the touchscreen gesture. For smartphones and tablet-based is AR, the touchscreen gesture like tabs, swipes, pinch to zoom, and primary input method. Everyone day-to-day life we are going to be use that. And get tracking, it's special attachments we required for you to have a head-mounted devices, HMT. In hands-free AR experience, particularly in the smart glasses, gas tracking allows user to select and interact with virtual objects simply by looking at them. A cursor or highlight appear where user gas is to be direct. And then the third one is your voice commands. And fourth is actually can tracking and gesture recognition. And fifth is the physical controller. And the last one is the eye tracking. So these slides which indicating all of them, whatever we discussed in the earlier one, how we are communicating with the augmented world may called as an input method. One is a touch screen, get tracking and voice commands, and hand tracking, gesture recognition, and physical controller with the help of joysticks and enable. And then last one is an eye tracking one. User focused deduction, intent understanding, and personalized content adaptation going to be taken here. And the next one is called as signal sources. So in detail about the signal sources going to be discussed in the further more chapters, the part 2 of the continuation of this one. Thank you once again.